This video is for section 1-4, properties of addition and multiplication. First vocabulary word is the word sum. The sum of A and B is the result of adding A and B. In symbols, that looks like this, A plus B. Next word is product, the result of multiplying A and B. There are a lot of ways to show products in symbols. One is with a dot, A times B. Another is with parentheses, where you write one of the things in parentheses. This means multiply. And even just writing the letters side by side means multiply. In a sum, the two numbers that are being added together are called terms. In a product, the two things that are being multiplied together are called factors. And those words, terms and factors, will be used quite a lot in Algebra 2 class. Next, let's talk about some more axioms, which are assumptions that we make in order to do math. The first is the axiom of closure for addition and for multiply. Let's assume that A and B are any two real numbers. Then when you add them, the answer is a real number. And when you multiply them, the answer is a real number. The word closure is used to indicate when you add together two real numbers, you get a real number. You get the same kind of number as the numbers that were added. Next, let's discuss the axioms of equality that you know from Algebra 1 class. Let A, B, and C be any real numbers. First is the reflexive axiom. A equals A. Is this common sense to you? That 5 is equal to 5? Next is the symmetric axiom. If A equals B, then B equals A. Is that common sense? You use this in Algebra 1 class when you solved equations. For example, if 1 plus 2 is equal to 3, then 3 is equal to 1 plus 2. Next is the transitive axiom. If A equals B and the B is equal to C, then the A is equal to C. Does that make common sense? Here's an example with numbers. Let's say 4 plus 2 is equal to 6, and that 6 is equal to 5 plus 1. Therefore, 4 plus 2 is equal to 5 plus 1. Finally, the substitution axiom. If A equals B, then A can be replaced by B, and the B can be replaced by A. You use substitution a lot in Algebra 1 class. Here's an example of how you used that. Let's say a math problem has 2 plus 7 in it. You could replace that with 9, because 2 plus 7 equals 9. Next, let's review the commutative axiom. If A and B are real numbers, then A plus B is equal to B plus A, and A times B is equal to B times A. The commutative axiom is what allows you to change the order of the terms in a sum. Here's an example of how you used that in Algebra 1. Here's an equation. This equation is not in slope-intercept form, but you can change it to slope-intercept form by reversing the order of the terms in that sum. Next, the associative axiom. If A, B, and C are real numbers, then adding the A and B first and then adding the C is equal to adding the B and C first and then adding the A. Notice the same is true for multiplication. We use the associative axiom all the time without even thinking about it. For example, let's say we wanted to do this math problem. One way to do the problem is to add 2 plus 99 first, getting 101, and then add the 1 and get 102. But another way to do the problem is to add these first, making a very convenient number 100, and then adding the 2 to get the answer 102. Now, either way is fine, but this second way might be faster. Let's summarize the lesson. We discussed more of the axioms, which are assumptions that mathematicians make about numbers that allow us to add them and multiply them conveniently. We'll make use of these assumptions all throughout the year as we work algebra problems.